Hey everybody, Trey here. Welcome back to another forecast discussion. We've had an upgrade in severe weather probabilities across parts of the southeast today. We have an enhanced risk out now for parts of northeast Louisiana into western and central Mississippi, including the Jackson, Mississippi area. Big old slight risk surrounds that up to the central Arkansas vicinity near Little Rock, down toward Shreveport, far east Texas, and down toward the Louisiana coast, with a marginal risk extending up into north central Illinois and out to the east across central Tennessee into central Alabama. All hazards on the table for today. We have a 10% tornado risk area there, coinciding with that enhanced risk, and a 5% area surrounding that as well. Damaging winds also a threat today, as well as some hail, although I think that will be a tertiary threat. I think the damaging wind and tornado threat are going to be the most concerning threats for today's event. So let's go ahead and dive into some meteorology for today. We'll start off, as always, with our water vapor satellite imagery, and you can see that we have a nice, well-defined swirl right here in the flow, kind of elongated here, stretched out from the Central Plains down into western Mexico. But this is going to be our trough that will be our main focus for severe weather for today. You can already see some moisture registering out ahead of it. We already have some storms ongoing across Texas. Let's take a look at the radar here. We already have kind of this band of storms out here across central Texas, with this additional activity out to the east and northeast into Oklahoma and Arkansas. If you hear the rain outside, I'm in Norman right now, and we're getting some rain. So we are kind of north of the action area here in Oklahoma, but still getting some rain as well in Arkansas. But this band of storms is firing up. For now, we should see an increase in the overall intensity and coverage of storms as we go through the next few hours, especially out here across East Texas. And that's when storm intensity and severity will start to pick up a little bit as that trough swings through. Visible satellite imagery, you can see the band of storms here, those enhanced kind of clouds, convective-looking clouds there across Texas. That is going to be associated with that band of storms. Quite a bit of cloud cover across the region here, from East Texas all the way through Louisiana, Mississippi, and Alabama. Arkansas fully socked in clouds as well. So surface heating going to be fairly muted today. We're going to have to rely on that warm advection in the low levels to really start pumping that moisture northward. That warm air advection, or WAH as we call it, is simply the transport of warm, moist air into a given region. And that's what's going to happen today, and that is going to allow the low levels to destabilize and continue, or to moisten and allow the atmosphere to destabilize throughout the day today in lieu of significant surface heating that we'll see throughout the day today. We'll also be looking for any breaks in the clouds as well that will enhance that surface heating and enhance that overall instability for this particular threat, as the instability has kind of been the main question with this particular system. We'll talk about that here in a second. But we go to our upper air maps, and you can see that 500 millibar trough centered out here across the New Mexico-Texas border there. You can see it's kind of just stretched out here, its axis stretched out a little bit, positively tilted trough at this point. That will change as we go through the day today. This is going to become more compact, and it's going to take on more of a negative tilt as it swings through off to the east or northeast with time. So that'll be something to watch, and we'll take a look at some model data here in a second, as that will kind of increase the overall wind profiles in the atmosphere, making things more favorable for severe weather. We'll go down to 700 millibars here, take a look at any shortwave troughs. Don't really see a pronounced shortwave within the flow. Maybe one right in here you could call just ahead of the main trough axis, kind of one maybe right in there as well. But not seeing anything too notable here in this particular 700 millibar map. 850 millibars, we'll take a look at our low-level jet. With that strong upper trough moving through, we should expect a pretty strong low-level response here, and that's exactly what we're getting. Broad cyclonic flow here across the Red River region, with a very broad and strong low-level jet here centered from the eastern half of Texas into Louisiana and Arkansas. That will shift off to the northeast as we go through the day today, and we should have a strengthening of that low-level jet as well as that trough continues to move through, take on a negative tilt. We should see stronger surface low development and low-level cyclone development out in here across northeast Texas, and as a result, we should get low-level winds to strengthen. And as we know, that low-level jet helps to, number one, continue to pump that low-level moisture and rich air, juicy air out from the Gulf into the region, and number two, that will increase the overall low-level shear and improve the wind profiles, making it favorable for significant severe weather later on today. Let's go down and take a look at our surface data here. Let me refresh this so we have our up-to-date view. So you can see where exactly our frontal zone is located. You can see some northeasterly winds here across central Texas, southerly winds here across far east Texas into Louisiana. So we do have definitely a frontal zone situated right in this region here. And if we go up, so actually look at right in this region across northeast Texas, we're already starting to see some pretty well-defined surface low development. You can see those winds shifting from northeasterly or northwesterly, to westerly, and then southerly, and then back to easterly there across far northeast Texas. So we're getting to see surface low development right now across that region, that cold front extending down to the south from that surface low. We should have a warm front kind of setting up somewhere in this vicinity. You can see the winds shift from southerly to easterly here across Arkansas. Warm front in this vicinity, and that will continue to lift northward with time. Again, that surface low will continue to strengthen with time as well, and that will eventually start lifting off toward the northeast as we go through the afternoon today. That will allow the warm sector to make a farther northward advance and broaden across the region, giving us plenty of room for lots of storms here, potentially some prefrontal storms as well. So we will take a look at some soundings now. Let's start here at Lake Charles, Louisiana. So Lake Charles showing decent moisture in the low levels here. A little bit of dry air there in the low levels, not a very deep moist layer as we like to look for in these severe weather events. We do have a little bit of an inversion aloft here, a little intrusion of dry air and some semblance of warmer air aloft. That is going to erode probably pretty efficiently as we go through the day today as that trough swings through. That inversion will be lifted and cooled as that trough moves in. So not too worried about any capping inversion here. So we should see weak capping over the open warm sector, which should provide plenty of opportunity for storms to fire out in the open warm sector. Shreveport here this morning, fairly saturated looking profile, a little bit of an inversion there near the surface, but that should, as we said, the low level warm air advection should allow these temperatures and dew points to rise here across the region, and that's how we will get a little bit more instability in this particular environment. Notice the wind profile, already fairly favorable for severe weather. You can see sorry about that. Bulk shear, a little on the weak side. These photographs are fairly small, only about 25 knots of effective bulk shear at this point. So definitely on the margins for supercells. Again, that will increase with time as that trough finally moves in. We should see a lengthening of these photographs. But notice the low-level photographs already. Very strong curvature there in the low levels, lots of veering in those low-level winds, and that will only increase as that low-level jet ramps up. Going toward late afternoon into early evening, right around sunset or just after, that low-level jet will really ramp up, and we should see a stark increase in the size of the low-level photographs, as well as the deep-layer photographs, as the upper-level winds start to move in with this particular activity. So let's take a look at some model data now. This is the 12Z NAM run, hot off the press here. This will start at 500 millibars. You can see that trough located across eastern New Mexico, West Texas, taking on that little bit of a positive tilt. Notice what happens with time, though. As we said, that trough going to swing through and really take on a much more negative tilt, become a lot more compact. You can see the size of the trough has decreased a little bit. That stronger flow rounding the base of that trough, concentrated just out in the exit region of that trough. Strong divergence, directional divergence in the winds here at 500 millibars. Usually we use the 250 millibar, 300 millibar level to show this, but if we look at our 250 millibar map, not really seeing a response here associated with this 500 millibar trough. So this is a very compact shortwave trough here embedded within the flow. But nonetheless, we see strong diffluence or divergence, directional divergence aloft here across this region. We've talked about that before. Those winds spreading apart aloft the atmosphere doesn't like that, so it tries to bring up air from below to fill that void. And that's how we get large-scale rising motion for severe storm initiation in a given environment. So that shortwave moving through, very potent shortwave, it's going to really start to swing through the region by right around sunset to just after sunset. So we may see an increase in overall convective intensity and coverage here as we go into the right around sunset into the early evening hours across the region. Although we will have multiple forcing mechanisms for storms out here both along the surface cold front, near that surface low as well, and perhaps in the open warm sector. And we'll get into that just in a second here. So here is our 850 millibar map, low-level jet centered across the region. You can see that swath of stronger winds, 30 to 40 plus knots of flow there across East Texas into Arkansas and Louisiana. That will continue to strengthen and broaden throughout the day as we get continued cyclogenesis here out across the Red River vicinity. You can see those winds start to ramp up there about a kilometer off the surface here at 850 millibars. That continues, and then look what happens overnight. 3Z, 6Z, we get a huge broadening of that low-level jet here, especially across Mississippi into Arkansas, western half of Tennessee into the Illinois, Indiana vicinity there. So very, very strong low-level jet after dark. That could really heighten those wind or strengthen those wind profiles. Could see some more embedded tornado threat with these storms as we get into the overnight hours there. This is 6Z right around midnight or so. So the interesting development there. That low-level jet really ramps up. We have an adequate low-level jet, more than adequate low-level jet throughout the region through much of the afternoon. We'll go down to the surface here as well. I'm going to zoom in here to our Southern Plains sector so we get a closer view. So our initialization here with this particular model run shows that surface low starting to develop in northeast Texas like we showed on the surface map. Cold front extending down to the southwest there from that surface low. Warm front centered somewhere in this vicinity right in here. And again, that low is going to lift off toward the northeast with time, bringing that front northward, the overall warm sector northward. And once that trough finally moves in, that upper level trough finally moves in, we'll start to see this cold front surge a little bit off toward the east, and that will be an impetus for storm development. Mostly a more linearly organized complex there along the frontal zone, away from that warm sector convection. So we go with time, and you can see that low starts to strengthen, intensify, and really starts to push off toward the northeast. By 0Z, so 6 p.m. Central Standard Time, warm front located up here into kind of central to northeast Arkansas, Missouri Boot Heel vicinity. Does include Little Rock. Little Rock is right there. Pine Bluff right in there as well. Cold front stretching out to the south of that, right through that pressure tongue. So that cold front will have a band of storms along it as well. And we'll also be watching the open warm sector for any development. I am seeing a little bit of evidence of potentially some semblance of perhaps a prefrontal confluence band in the open, or prefrontal trough here in the open warm sector. SPC actually mentioned that in their discussion this morning. We'll take a look here at this. This afternoon, amidst the mass response to the approaching mid and upper trough, a prefrontal zone of low-level confluence and convergence should intensify over the Gulf off the upper Texas coast, extending northeastward into parts of western and central Louisiana. This corridor of warm sector lift should expand or extend to western Mississippi into early evening. So they are expecting to see some sort of low-level confluence band take shape here across the region, especially today. So we'll look here this afternoon. So this is our cold front at 21Z. Cold front's back in here. Seeing maybe a little bit of kinkiness, if you will, in the flow out here across Mississippi into kind of southeast Arkansas. That could be a little bit of a prefrontal trough south of that warm front that may be an impetus for more isolated development out here in the open warm sector. Not really seeing a huge, a very notable low-level confluence band in this particular surface map. Perhaps the resolution isn't quite high enough to make it out. We can also look at 850 millibars for any kind of sort of low-level confluence that may not show up at the surface, but does so at 850 millibars. That is a pretty frequent signature with these type of events. And perhaps there might be one a little bit in here. You can notice the streamlines kind of go like this here, whereas over here they kind of are going like this. So maybe a very subtle confluence band setting up somewhere in this vicinity right in here across southwest Louisiana, extending up into north central Louisiana as well. So that'll be something to watch. We'll have to keep a close eye on our surface data as we go through the day-to-day to see if we see any confluence areas out in the open warm sectors. That would, as we know, provide a little bit more subtle forcing and allow for more discrete storms. And in this kind of environment, any discrete storm may have the potential to produce more significant severe weather than along the line. Of course, along the line, we will see the threat for damaging winds and a few tornadoes. Let's take a look at a couple soundings here across the region. I'm going to take one here just out ahead of the cold front, just into western Louisiana. Then we'll take one here across southeast Arkansas, right at the Louisiana, Arkansas, Mississippi confluence there. How about? So here, ahead of the cold front, 21Z, about 3 p.m. or so, you can see decent instability here aloft. A little bit of dry air there in the mid levels. Shouldn't be too much to worry about there, but decent instability, 1,000 to 1,500 joules per kilogram of mixed layer CAPE there. Decent low level instability, 3 CAPE about 150 joules per kilogram. So low level instability looking solid. Decent instability through the entire column. Low level shear, definitely on the stronger side there, 200 meters squared per second squared effective storm relative helicity. That spin in the low levels of the atmosphere. Bulk shear still kind of on the margins though, only about 32 knots here or so. Photographs still remain a little bit on the small side, so we may see a tendency for storms to start out a little bit multicellular, especially farther removed from the frontal zone and the trough. You see here, this is our open warm sector at 21Z as well. Definitely have decent instability, 1,300 joules per kilogram of CAPE, low level CAPE about 150 joules per kilogram. So thermodynamics not going to be a huge issue. That's kind of been a question throughout the last few days with this setup. Instability may be a little bit on the skinny side, which may tend to limit the robustness of updrafts just a little bit. We like to see a little bit more of that fatter CAPE, but still adequate instability for robust, severe storms. Low-level shear, definitely strengthening here in the open warm sector. Definitely low-level shear favorable for perhaps a tornado or two with any warm sector activity. But look here at the effective bulk shear. 23 knots of effective bulk shear. That is definitely lower than the threshold for supercells. You might see some stronger multicells with this activity, but I think it's going to take a while for these storms to start to really percolate until that low starts to move off toward the northeast. That 500 millibar trough starts to move in. That's when we'll start to see that shear really increase towards 0 to 3Z or so. And then we will start to see the severity of the storms increase. But for much of the afternoon, I think we'll stay somewhat with a multicellular mode, especially out here across the open warm sector with any development that can fire there, with the deep layer shear being so weak. Along the front, a little bit more of enhanced shear closer to that frontal boundary, closer to the trough, helps get that shear up into the marginal category for rotating storms. So would expect to see the severity of storms along the frontal zone increase first. And then as that trough moves in, we'll go to 0Z and take a look here. We'll look at our moisture. Moisture is not going to be an issue with this event. You can see broad warm sector across the region. So let's go to 0Z and take a sounding out ahead of the front here. And we'll take one out ahead in the open warm sector, kind of at that confluence of Louisiana, Mississippi now, and Arkansas. So you can see what happens between 21 and 3Z. Number one, our low-level jet really starts to ramp up here. Very strong-looking photograph there for supercells. Very strong low-level shear, effective storm relative helicity, over 300 meters squared per second squared. So a stark increase in that low-level shear. But also look what happens to the deep layer shear. Photographs have lengthened quite a bit, and bulk shear now at almost 50 knots. So that between that 21 to 0Z time frame is kind of that sweet spot when we'll see storms start to really ramp up across the region. Any prefrontal storms, once that trough moves in, once that low-level jet starts to ramp up, we'll start to see those storms intensify finally as that deep layer shear increases. Out here across the warm sector, still struggling a little bit with the shear, just about 33 knots, but definitely an increase from what we saw at 21Z. So that we should be starting to see marginal deep layer shear for supercells out in the open warm sector. Low level shear definitely increasing as well. Over 250 meters squared per second squared of effective SRH here in the warm sector. Instability still on the skinny side, but still more than adequate, approaching about 800 joules per kilogram. So we've seen kind of a decrease in the overall instability as we go through with time. That's an interesting trend there with the usually aggressive NAM. NAM's usually aggressive on the instability side. Still adequate, though, for severe storms. That moist layer continues to deepen there. You see that moist layer extending all the way up into the atmosphere, a very saturated layer above about 700 millibars there. But nonetheless, wind profiles are very favorable for severe weather. And let's take a look here, go a little bit farther with time. We'll go to 3Z. We'll take one here a little bit farther north across the Mississippi River Delta. Across eastern Arkansas, northwest Mississippi. We'll take one farther south as well in that enhanced risk area. So this is at 3Z. Instability definitely a little bit minimized there, but low-level shear very strong there across the area. And this is at 3Z as well. So instability, again, going to be a question, especially as we lose our daytime heating. Any breaks in those clouds, we're going to lose by 0 to 3Z, and that may temper the instability a bit. But in these strong low-level shear cases, you don't need a lot of instability to get rotating thunderstorms out of this event. Wind profile is definitely still favorable for severe weather. Instability, though, going to be on the weaker side with this particular event. So let's go ahead and take a look at some model data. Of course, as we go on with time, that warm sector pinches off. We'll start to see those storms kind of outrun the warm sector there. But sweet spot going to be probably about 22 to 23 Z, about 4 to 5, 6 p.m. or so. We'll start to see a ramp up in the intensity of those storms, and then we'll get a few hours there of intense storms across the risk areas. Let's take a look at the HRRR first. We'll go and do that. We'll take a look at the latest run, which is we'll take a look at the 12Z run just for simplicity's sake. We'll go to simulated reflectivity here. So as we saw lots of storms starting to percolate here across Texas. Those will continue to increase in coverage with time. Notice that storms just kind of putz around a little bit. We don't really see an intensification of those storms for quite a while. And then we start to see storms both along the frontal zone out here across East Texas and in the open warm sector. HRRR predicting quite a bit of coverage there in the open warm sector near any confluence bands that may develop. You don't see a very intense storms though until about 22, 23Z. We start to see an increase in the overall intensity of those storms as that low level and deep layer shear starts to increase. If we can get more of a semi-discrete mode out here in the open warm sector, again, weak capping in the open warm sector, so perhaps a lot of storms will fire, but we'll have to watch for any semi-discrete storms as in that kind of environment. As that deep layer shear picks up, they will have the chance of producing tornadoes and some damaging winds. You can see kind of two separate areas there. This is along our cold front. This is along any prefrontal confluence and even some more out ahead of that main prefrontal confluence band. So kind of multiple areas of storm development will kind of merge into one as we go into the overnight hours, moving into Mississippi and Alabama. As that low, you can see, lifts off toward the northeast there. So kind of a messy storm mode overall. Strong forcing near the cold front, closer to that trough. More of a linear organization of the storms along the front. Weak capping in the open warm sector may allow more storms to fire than normal, but of course we know those confluence bands tend to be a little bit weaker on the forcing side, so we may have to watch for a little bit more semi-discrete development out here across the open warm sector. Take a look at the WRF ARW here, just to get another convective allowing model in here. This is the 12Z run. You'll notice here, not much, kind of a lull in activity between about now and 2021Z or so. Then we finally start to see things percolate across the region. Prefrontal confluence band out in here. Just kind of a messy storm mode overall. Perhaps some semblance of maybe more discrete development out ahead of this confluence band. But with time, just kind of a messy storm mode turns into a line as we go through to Mississippi and Alabama, as we go through the overnight hours. One more cam here, WRF, the NSSL WRF model. Probably going to show much of the same thing here. We'll go through with time and just a lot of development out here in the open warm sector by 20 to 23 or 0Z there, and definitely a similar situation to what we were seeing with the other convective allowing models. So that's going to wrap things up today. Once again, I think the main risk is going to start to percolate about after 20 to 21Z, after about 2 to 3, 4 p.m. or so, because that overall deep layer shear is going to remain weak until that trough starts to move in. But we do have that enhanced risk area there for eastern Louisiana into central Mississippi, including Jackson, Mississippi. A little surprised that this isn't just a tad farther north. We are seeing a little bit enhanced low-level shear there near to that surface low, which will be kind of up in here. So I was a little surprised to see the enhanced shifted farther south a little bit. But nonetheless, this slight risk area does encompass that region, and that will have a tornado and damaging wind threat as well. We'll have to watch again for that storms along the cold front, organized more into a line, more of a damaging wind and embedded tornado threat. Stronger low-level and deep layer shear for a longer time, so those storms will probably be more severe first along that cold front, shifting off toward the east, and then we'll have to watch for prefrontal development in the late afternoon to early evening hours as that low-level jet ramps up and that deep layer shear ramps up out there. Supercell, again, I think storms will start off as kind of multi-cell, just kind of garbagey storms out here in the open warm sector, and then once that deep layer shear starts to increase, that low-level jet increases as well towards sunset and into the early evening hours. That's when we'll see a ramp up in intensity of storms out here in the open warm sector. Both regimes will kind of mix into one as it moves toward Mississippi into Alabama overnight, and then it will eventually run out of instability as we go into the late night and early morning hours tomorrow. So that's going to do it for this forecast discussion. Thanks for watching, and we'll see you in the next video.